3 Atlas has just flown past our Sun, and this close encounter has revealed something new about our interstellar visitor that only deepens the mystery of its true nature. If this thing is a comet, then it continues to be the strangest comet we've ever seen. And if it's something else, then the world is about to find out, because 3I Atlas is coming for us next. There is a very interesting coincidence about this interstellar object arriving right now in 2025, because this year marks a time when our Sun is experiencing its peak activity. We call this period the solar maximum, and it only comes around once every 11 years. During this peak, the surface of the Sun gets whipped up into these giant storms that produce solar flares and coronal mass ejections, which is basically what happens when a big chunk of the Sun's atmosphere gets blasted out into space. Many of these solar ejections will hit the Earth, and that's why people all over the world have been seeing brighter and more vibrant auroras in the northern sky throughout 2025. That is pieces of the Sun bouncing off our own atmosphere. Our solar maximum began in October 2024, and it typically lasts for about 1 year. So we are just coming off of the peak right now, and this is when 3I Atlas makes its approach. For any comet, interstellar or not, the most interesting time in its life cycle is going to be when it passes close to a star. We call this phase perihelion, when the distance between the object and the Sun is at its shortest. During this time, the object is getting bombarded by energy in the form of heat, radiation, and the coronal mass ejections. So, the same charged particles from the Sun that create the northern lights are also hitting 3 Atlas. Prior to this phase, 3I Atlas has been very difficult to get a good look at because it's been so far away. There's a new image that was just released by NASA earlier this week, and it's actually the highest resolution photograph of 3 Atlas that will ever be taken because it was captured by a satellite in orbit around Mars at the closest distance this object will ever come to any planet. So, we were pretty hopeful that this would provide some new details or insights into what 3 Atlas really is. And as you can see, it looks like a big fuzzy white dot. Not the most captivating image, and unfortunately no big mysteries revealed, but stick with me. We've got much better stuff coming in just a minute here. Now, you've probably heard that we were not able to see 3I Atlas as it flew past the Sun, because the Earth was stuck on the opposite side of the solar system. And that is mostly true, but there are a couple of exceptions. There are 2 satellites in Earth orbit that are equipped with very special telescopes designed to stare directly into the Sun. It's actually pretty simple. You just put a disk in the middle of the telescope that perfectly lines up with the surface of the Sun. This blocks out the brightest light and allows you to see the atmosphere around the star, also known as the corona. This is a great way for us to monitor the weather patterns of the Sun and spot things like solar flares and coronal mass ejections. But it also allows us to see objects around the Sun that would otherwise be hidden behind the bright light of its surface. So using the space-based coronagraphs on board the American GOZ and the European SOHO satellites, we were able to observe the changes experienced by 3 Atlas as it traveled through its perihelion. The first thing that happened on its approach to the Sun was a rapid change in brightness. 3 Atlas started glowing with light. Of course, it would make sense for an object getting closer to a star to also appear brighter, but this was not a subtle increase. This was a very dramatic rise, with the object becoming about 400 times brighter than it had been just days before. A typical comet flying past the Sun might experience an increase in brightness of somewhere between 10 and 100 times, depending on how close it gets. So, what 3i Atlas did was far more extreme than anything we've seen before. But not only did the object get a lot brighter, it also changed color again. Now, when we first started observing 3i Atlas back in the summer, the light reflecting from its surface was mostly red. That doesn't necessarily mean that it would look red to the naked eye. It just says that the spectrum of light was closer to the color red than any other color. This is normal for a comet because comets are surrounded by clouds of gas and dust. We call this the coma, and that dust tends to reflect a lot of red light. Since 3i Atlas also has a coma of gas and dust, the red color actually made sense. One of the few normal things about this object until 3 Atlas mysteriously turned green in early September, and we still don't know why it did that. But then, as it got closer to the sun, it actually changed color again, from green to blue. That is pretty weird, because we would typically expect to see a natural comet become more red as it gets closer to the sun. Here is a color spectrum for reference, so you can see that green is kind of in the middle, and if we were expecting the light to shift towards red, it would actually have to go in the total opposite direction to reach blue. Now, when we combine the massive change in brightness with the highly unusual change in color, we are only left with a couple of natural explanations. One is that 3i Atlas suddenly started to release a massive new cloud of bright blue gas. We are not exactly sure what kind of gas that would be. It's definitely not anything normal for a comet to release, but that doesn't necessarily mean it's unnatural. Explanation 2 would be that this is the beginning of a breakup event, that the Sun has actually destroyed 3 Atlas, and we are watching it fracture into smaller pieces. Again, not an unusual thing to happen to a comet. Many of them break up as they travel through the inner solar system, but we know that's not the case here because we've already seen 3 Atlas come out the other side intact. Of course, there might be a third explanation for all of this, but you might want to secure your head with a piece of tin foil for this one. If there was anything that 3i Atlas has done so far that would indicate alien engine technology, then this would be it, because the Sun alone did not create this change. It came from within the object itself. And again, it could be just gas. But then we have to explain what 3i Atlas does next. Following the bright flash of blue light, the object actually changes its course. As 3i Atlas enters its perihelion with the Sun, it starts to experience non-gravitational acceleration for the first time, which means that it is moving under its own propulsion. And this thing is moving fast. The massive gravity well of the Sun is going to affect the velocity of any object that comes near it. We know that, and it's something we can easily predict and account for. But anything outside of that predicted change is going to fall into the category of non-gravitational acceleration, or NGA, which means that the object can go faster, slower, up, down, diagonal, doesn't matter, just as long as the movement is separate from the gravity of the Sun. Now, we would expect a comet to experience non-gravitational acceleration during its perihelion with the Sun. That is not weird, because all of the gas being released into the coma is going to have a tendency to push the comet around a little bit. This only makes sense. But as with so many things involving 3i Atlas, it's the extreme nature of the object's movement that makes it stand out as being unnatural. From the entire time we observed 3i Atlas on its journey through the solar system, there was almost zero detectable NGA. It held a perfectly straight course all the way along its approach to the Sun. This is not exactly normal, because most comets tend to wobble around a little bit as they release gas and dust from their coma and eventually form a tail. Then, the closer they get to the Sun, the more change in direction they experience as more stuff gets released into space. But no comet has ever experienced such a drastic acceleration as 3I Atlas. On the day that 328 Atlas was at its closest distance to the Sun, which was October 29th, the object was observed to change direction away from the Sun by a distance of 135 kilometers, and that was combined with an acceleration relative to the Sun of 60 kilometers per second. So we get a combined total of about 200 kilometers per day. Now, what does that mean? Well, we can look at the interstellar comet 2 Ebour-Borisov, which would be the closest comparison we have for something like this, and that object was observed making about 100 kilometers per day of non-gravitational acceleration, only half of 3I Atlas, or using a more typical solar system comet like Hale-Bopp as an example, which was another large object with powerful outgassing similar to 3I Atlas, but that comet only experienced about 1% of the amount of NGA that was observed for Atlas. So, the effect of the Sun on 3 Atlas has made it brighter, bluer, and has it moving even faster than any other comet ever observed. That is pretty strange already. But then this happens. Here is a photo of 3 Atlas taken just a few days after its closest encounter with the Sun on November 8th. And now we are seeing this complex structure of gas shooting out from the core of the object. So what we are looking at here in the middle is that bright glowing halo around 3I Atlas, which extends out around 500,000 kilometers in every direction. But then extending out much further from the halo are at least 7 distinct jets of gas firing into space. These jets are mostly pointing away from the Sun, but we still have a couple of smaller ones that are shooting directly into the Sun. This is unusual because we know that most comets form a tail. Again, we can use Hale-Bopp. Again, we can use Hale-Bopp as an example, known for its very large and distinct tail. And you can see that there are actually 2 distinct structures inside that typical comet tail. One is mostly dust, and the other is mostly gas. Since gas is lighter than dust, it tends to rise a little higher, but the 2 of them always travel in the same direction, which is away from the Sun. That makes sense. But for 3I Atlas to go from showing basically no tail at all to these 7 jets blasting towards and away from the Sun, that's just really unusual. It's also a bit strange for these jets of gas to have such a distinct structure. Because 3 Atlas is a rotating object, it spins around once every 16 hours. So, if these were just random puffs of gas coming out from the surface, then the rotation would kind of smear them all together into one big fuzzy tail like a normal comet. But somehow, these jets on 3 Atlas are powerful enough to stand out on their own even while spinning. Although this did not last for long. Moving to our next image of 3I Atlas just one day later, and now it looks completely different yet again. Those small jets have now merged into what looks like one giant gas plume. It's now closer to what you might call a normal comet tail. But at the same time, it's also not like that at all. Instead of a long, fan-shaped, fuzzy streak, the tail coming off 3I Atlas looks more like smoke rising from a fire. This large plume is moving away from the Sun, and measurements put it at just under 3 million kilometers in length, which is a pretty gigantic structure to show up in just 24 hours. Now, even more interesting, if you look closely at the image, there is a second plume of gas coming out in the opposite direction from the large one, an anti-tail. It's closer to about 1 million kilometers in length, and this is moving in the direction of the Sun. Now, you might remember that one of the first odd characteristics of 3I Atlas observed back in the summer was the formation of an anti-tail, or a sun-facing emission, which is highly unusual for any comet. But at the time we first saw the Anti-Ale around 3 Atlas, it was still pretty deep out into the solar system between Mars and Jupiter. So, the energy it was receiving from the Sun was still relatively weak. Not only does the Sun make heat and light, but it also sends out waves of radiation into the solar system. This all combined kind of acts like a solar wind that blows away from the Sun. And that's the force that typically shapes a comet's tail. But now that 3I Atlas is moving through the inner solar system, still pretty near to its closest distance from the Sun, and still managing to push out this relatively huge sun-facing tail. That's just not the kind of thing that a normal comet would do. And the fact that 3I Atlas has managed to lose all of this gas and dust in these multi-million kilometer-long plumes of debris, yet has managed to stay intact and not break apart under the pressure. That tells us that this is an extremely massive object. There has been a lot of debate about the actual size of 3I Atlas, meaning the object itself inside the big cloud of gas and dust. On the conservative side, it's thought to be 5 kilometers wide, at most, maybe less, but other estimates have put it at something more like 10 kilometers across, and that's more likely to be the case given what we've seen. That makes it 20 times larger than the first interstellar object, Oumuamua, and 10 times larger than the second interstellar object to Ebosaf, which was already on the large side for what we thought an interstellar object was capable of. And it's important to understand the probability of something this big surviving a trip through interstellar space for billions and billions of years. It would make sense that something small might squeak through and avoid hitting anything. But the bigger it gets, the more unlikely that becomes. And then to have this thing just happen, to fly right past our Sun at a time in human history where we are actually able to observe it and recognize what it is, that is 1 in a million. So regardless of what 3I Atlas might be, a rock, an alien, a weird comet, it's undoubtedly a very special object. And that's why the scientists at NASA are working so hard right now to try and figure out just what exactly it is we're looking at. They have spacecraft all over the solar system that have been watching 3I Atlas for months, taking measurements, sending data, and now it's a matter of trying to understand the story within that data. This is not a fast or easy job to do, and we are going to be very lucky to have another great opportunity to learn more about 3I Atlas on December 19th, when it will come within its closest distance of the Earth. At that time, all of our most powerful telescopes, both on the ground and in space, will be trained on this object yet again, and there's no telling what we're going to find. It's probably going to be something you'll want to see.